Okay, moving on with this chapter, we're going to be looking at testing claims, and we're going to be looking at single samples. The last section, we looked at confidence intervals. We took a sample, one sample, and we took that sample and generalized it to the population. We used that sample to judge where we think, gave us a range of where we think the population average would be, where the population proportion will be. Well, now we're going to be using that single sample, and we're going to be testing claims. So how do you test a claim? We're going to see if that claim is true. Does the sample justify or verify that that claim is true or not? Okay? Now, with all these tests, just like with confidence intervals, there's conditions. We are going to assume all conditions are satisfied. Okay? So all the tests that we are running are valid tests. We're not going to go through the conditions for each one. Now, testing these claims, the beginning step is making up statements. And these are the statements that we're going to be judging. Do we side with this statement? Do we have evidence to prove this statement or to say that this statement is correct or not? Okay? So, statistics are used to make conclusions and support theories. Okay? And that's what we're going to be doing. We're going to be looking at claims, and we're not just find evidence to say this claim is true, this claim is false. Okay? Things like this. You teach 2 Algebra 2 classes. One has an average of 83, the other has an average of 82. Okay? What we're going to be looking at to see if, just glancing at it, you want to say the 83 class is higher. Okay? What we're going to be judging, though, is to see, is that consistently true? Is there enough evidence between those two classes to say that, yes, this class, in this case, is a higher grade, and that's consistently going to happen? So, this would be the claim or the question we're asking, is the one class better than the other? That would be what we're going to be judging and seeing which one is, if there is evidence to show that that 83 is high enough. Because some people are going to look at it and say 1 percentage point. Well, 1 percentage point doesn't mean that much. It's not worth that much. But if we have 2 very large samples, there could be enough evidence there to say that that 1 point is a big enough difference. And we start saying things they are statistically significant. Okay? A nice little definition kind of generally saying statistically significant means, is there a big enough difference to say that the event did not happen by chance and it will happen consistently? Happening by the word chance there, I think, is one of the most important parts. Because if we're looking at that 83 compared to the 82%, well, if there's not a statistical significance, if we run our test and we say, no, there's not evidence to say there's statistical significance, that 83%, yes, it happened this time. You take another look a little later, it might flip, okay? Things might go bouncing back and forth. By chance, that class got a higher score, okay? But if we say there is statistical significance, it's not by chance. Something made that happen. Something is causing things to increase, things to decrease, and that's when more investigation is needed, okay? More exploring needs to happen. Now, the first step in writing these hypothesis tests is coming up with our statements, okay? So things like, you will lose 25 pounds in 3 weeks taking glucagon diet pills, okay? There's the claim. Now, if we were running a test, we would have to write out 2 scientific statements, and those 2 statements are what we would be judging, okay? So we would then write out our 2 statements, and then we take a sample, run the experiment, and we would judge, is this true or not? Every antibacterial pill produced by a drug Inc. factory will contain 5 milligrams of sulfa. Again, we would write out our 2 statements, okay? Here's our 2 statements to judge. We now take a sample, do the calculation, run the test, and we would see, is this claim that that factory has 5 milligrams of sulfa in it, is it true or not? These are examples of things that we are going to be running tests on, okay? Now for each one of those, I start off by saying, okay, we have our 2 statements. We write out our 2 scientific statements, okay? Those scientific statements are the null hypothesis and the alternative hypothesis, okay? The null and alternative are starting points. Anytime we're doing testing and claim, we need to have that null and alternate for the tests, okay? These are the statements that we will test to see if they're true or not. They're the 2 things that we're going to be judging, and you can almost look at these 2 things, I say this very loosely, kind of as opposites, okay? One's going to be saying directions going one way, the other's going the other direction, okay? Now the null the null is always going to be equal to. We say the null is the status quo. Okay? This is if everything is fair, if everything is completely done randomly, that means our test, whatever we're running, if it's an average or a proportion, that average or proportion is staying the same. Okay? And that's why it's always equal to. So when you're writing these out, we have our null label, that HO, that's our null label. And then we have our scientific equation for either the mu, this is for average, and then P is for the proportion. Okay, you also might see pi for P as well. Okay, so not too often. Oh, sorry, can't really see that. Not too often, but sometimes you will see pi as well. These are talking about the population. The mu is the population average. P or pi is the population proportion. And then after those equal signs, you would have whatever value that we're testing. Okay? So you're always going to have your null O, your HO for the null as labeling, and then you don't have to decide, are we talking about a average, which is quantitative data, or are we talking about a proportion, categorical data? You're going to have to come up with those. Now the alternative is more talking about the claim that we say is happening. That's either going to be H1 or HA. I like the HA better. You're going to probably see that more. That's usually what I have on my answer key. And this is either going to be less than, greater than, or not equal to. Okay, so that's what the same symbol, it's always going to be mu. It's going to be the same value in both of these, but this is the symbol you're going to have to get off of the question. Reading the question, reading comprehension is very important. Understanding, do we think things are increasing, meaning we think the proportion is going up, greater than? Is it decreasing, less than? If we just think it's different, okay, or we want to see, is it staying the same? Doesn't really matter if it's going up or down, we have not equal to. Okay, but again, each one, you're always going to have HO, HA, then you have to decide average or proportion, depending on which one is on, depending on what symbol you're going to use. And you're going to have a null and alternative for each. So let's go through some examples. A huge goal of the supermarket is to get the customers in and out of the store as quick as possible. This is the reason the express lane was introduced. Research was done and it was found that a high volume of customers run in and buy an average of 7 items. This was done in 1973. 25 samples were taken and it is now claimed that more than 7 items are being bought more often. Come up with the known alternative hypothesis for this event. So there's a whole lot of numbers going through here. Okay, we have a date, that's when this was taken, it has our sample size, and we're judging 7 items, okay? And it's saying that on average, 7 items are being bought. We want to see if that average of 7 is changing. So I'm going to start off with my null, okay? It has in there that it's average, so we know it's going to be the mu symbol, okay? So we have our mu symbol there, and the null is always equal to. So we know, we think back then in 1973, it was 7 items. That's the baseline that we think it is, and we want to see if it's changing from there. So I'm just going to label it mu equals 7 items. Now our alternative, all this stays the same. Okay? The same value should always be in both. The symbol, it's both averages. We have HO and HA, so we know which is which. Now we have to decide, greater than, less than, or not equal to. Since we think it says 25 cents were taken, and it is now claimed that more than 7 items are being bought at a time. So more, think it's increasing, we're going with greater than. Here's our null, here's our alternative. Okay? So that's what we would need, that would be our starting point for our test. And then we would start judging, okay, with all of our calculations, which one are we justifying? Are we saying it's staying the same, no, the average is still 7 items? Or is the claim true, it's being greater or it's going increasing from the 7 items? And we wouldn't exactly judge how much it's increasing, we would just say it is increasing, and then we would do some more investigating. The popularity of cell phones have been growing at an exponential rate. The average cell phone cost $145 in 1998. A sample of today's phones was taken and customers are complaining about the price of cell phones being greater. Okay? So we're looking at $145 is what, on average, what people are paying. So again, it's telling us it's an average. Null mu equals, I'm gonna have $145. The null is always equal to, so you should not get that wrong. It should be the equal sign. The alternative now, mu staying the same, $145, less than, greater than, or not equal to. So reading through here, the last line, customers are complaining about the price of cell phones being greater. So we want to test now, is the average price increasing? Greater than. So there's our null and alternative. We would start basing our answers on running our test and seeing which one we believe is true. And let's do one more example. The Maytex Pharmaceutical Company advertised that their top-selling blood pressure medication holds 500 milligrams of medicine per pill. The FAC is collecting a sample of the pills to test the Maytex claim of 500 milligrams. Okay? So it's saying that their pills hold 500 milligrams. So we're looking at null, mu equals 500 milligrams. Okay, just a quick label to have there. Alternative, mu 500. And now we need our symbol. Okay? It's not claiming that they're increasing that 500 or decreasing that 500. They're saying it is 500. So we just want to know, is there a difference? So I'm putting the not equal to sign for my alternative. Okay? Because they're not saying they're putting more than 500, they're putting less than 500. They're saying it is 500. So what we are questioning then, is it any different than 500 or just not equal to 500? Okay? So there's your null and alternative, okay, and that's always on be your first step. From there, we're going to have two methods of testing to see if we're going to reject the null or if we're going to fail to reject the null. Okay, the vocab is going to get very tricky the next couple of videos, so please pay close attention to how I write out my conclusions.